So how to change the speed of the any machine, nothing but AC and DC machines, by using the converters. So first let us discuss the speed control of DC motors. So back EMF formula is EB is equal to V minus IA RA. This is the standard formula of DC motor. And speed of the DC motor is equal to 5Zn by 60. Nothing but induced EMF, nothing but back EMF. This is 5Zn by 60 into P by A. So if I substitute in place of back EMF here, 5Zn by 60 into P by A. So poles and parallel paths and 60 and number of conductors are constant. So only that can be written as K times phi and speed is equal to V minus IA RE. So this is the V minus IA RA is equal to K times of phi and speed. So this is the standard equation. So by using this one, we'll discuss how to control the speed of the DC motors. So this is V is nothing but, so for example, if you take a DC shunt motor like this is a shunt to field winding, and this is the applied voltage. This is the applied voltage. So if you apply the voltage here, current passes to the load, and this is IA and this is IF like this. According to the speed, according to that the motor will run. According to the IA, the motor will run. So here the induced EMF is nothing but EB, back EMF. This is back EMF. So this is the back EMF. So now this is the input voltage. So I'm clearing this one, and V minus IA RA is equal to K times of phi and speed. So if you draw the DC shunt motor, this is DC shunt motor, and this is the field winding, and you are applying the voltage here. This is a V, and this is nothing but total current. This is armature current. This is field current. So here back EMF. So based on these three, we have these equations. So let us take a converter. Let us take a converter, whether it is half wave or full wave, whatever you like. So I'm taking a full wave converter. I'm taking. It is having how many thyristors? Four thyristors like this. So this is nothing but I'm taking reverse manner. This is load or output. Here I am taking input. Input is nothing but AC. AC, one winding, this one terminal is connected to here. Here and another one is connected to at this location. So we are applying this output voltage to input of the DC shunt motor. So this output is given to the input of a DC shunt motor. So in place of DC shunt motor, maybe DC series motor also available. You can give this output to input of the DC series motor. or DC compound motor or separately excited motor, whatever it may be. So here this output voltage is controlled by using alpha, nothing but firing angle of at various thyristors. Okay, now various thyristors. So as we can control the input voltage to the DC shunt motor or DC series motor or DC compound motor. So this is nothing but voltage. This voltage, if you reduce the voltage, so here speed is there now. Speed will be decreases because this is only direct parameter. If you increase the voltage, speed will be increases. In that way, we can control the speed of the DC shunt motor or DC series motor or DC compound motor. So, if it is separately excited, this is separately excitation will be there, TA start will be there. So, E flux also that is independent on this voltage. So, that equation will be written as V minus IARA is equal to K times of N only, because this flux is independent on this value, this voltage. So in that way also we can control the speed of the all DC motors. So this output voltage of the chopper. So this is chopper circuit. This output voltage, nothing but this output voltage is connected to the DC motor. This output voltage is connected to the DC motor. So as this motor is RL load, because this motor having inductive, nothing but winding. Winding is having resistive in nature and inductive in nature. So what we can call, this is a chopper. This is freewheeling diode, and this is RL load, isn't it? That is RL load. While charging, if you close the chopper, nothing but turn on, the inductor will store the energy in this position, in this way, and current flow in this direction. And if you open the chopper, inductor reverses its polarity and allows the current in the same direction. So current will be, during this condition, during turn on position, current to the inductor will increases. If you turn off the chopper switch, energy will be decreases, and again charges, discharges, decreases, increases like this. Charging of the inductor and discharging of the inductor through freewheeling diode. Nothing but the current, output current is, I output is continuous. Okay, we are reducing the supply, we are giving the supply in a intervals of time. We are not giving continuous output voltage, to the DC motor. But even though we are not giving the continuous voltage, it, current through the motor is always continuous. Current to the motor is continuous, so that the motor will run continuously. So what are the advantages of thyristor controlled drives? Nothing but by using thyristors, if we control the motors, what are the advantages? So first one is a greater, higher accuracy. Nothing but by giving the firing angle at a desired level, nothing but 180 variations are available, so that accurate speed we can achieve by using the thyristors, and a greater reliability. So this is better reliability because various options will be there, various locations, in various locations we can turn on this here. It is various reliability and higher efficiency. Why higher efficiency? Because there are no moving parts, that is one point. And another one is if the chopper input will be continuously, this is nothing but V input, we are taking only a small portion of input only, 50% of input only we are utilizing, so that we are reducing the consumption of electricity, so that efficiency will be more, and also more absence of moving parts, easy maintenance, because just by turn off the chopper we can maintain easily, and a low installation cost and low floor space required, nothing but area. Soft start and reduction mechanical stresses, because that is electronic switch. That is not a mechanical switch. Like you are using DPDT, TB, DP, TP, DT, like the TBDT switch, like that. So that is not a mechanical switch. That is a electronic switch, and the energy saving is more. So this is very well. This is the most important one. So by using the converters, we are reducing the energy consumption. And the disadvantage of the thyristor control. So major disadvantage is filters. Nothing but harmonics will be produces, because it is not correct pure form of DC. So output of the control rectifier is not a pure form of DC. So that is like this. This is not a pure form of DC. Just like that is a pulsating nature like this. Because of this pulsating nature, more harmonics will be present in the system. So that there is a major disadvantage. Because of this harmonics, temperature production will be more. There is a disadvantage. So heat. So heat. So because of this harmonics, heat will be more. These are the disadvantages of the chopper and advantages of the chopper. So these are the advantages of this one. So factors affecting of the speed control of DC motor. So there are two ways to control the speed of the induction motor. One is by using field control, another one is armature control, another one is voltage control also. So that is, so we can control the field control. We discussed field control and voltage control by using the rheostat, but by using the voltage control. Voltage control is possible with power electronic devices. So these equations I already discussed. So this is again I will write. So V minus IARA is equal to K times of phi into N. So N is directly proportional to V minus IARA by phi. This is the equation. This is the equation. So I already discussed that one. So this is a armature control, you know very well. This is field control, and this is nothing but a by varying voltage. So voltage control, by decreasing the voltage, speed will be decreases. By increasing the voltage, speed will be increases. Nothing but input voltage. Speed control of DC motor by using the converters. He gave the different types of motors and type of converter is used. Look at this one, below 1 kilowatt up to 5 kilowatt, 7 kilowatt, 400 and above 5. So 1 kilowatt means less capacity. Less capacity, half wave is enough, half wave control. As capacity increases, we should give more output voltage. Nothing but that is possible with a single phase half bridge. Half bridge nothing but two thyristors will be there available. Half wave nothing but only one thyristor. Next to 5 kilowatts to 75 kilowatts, three phase half bridge. So 75 to 400 kilowatts, three phase full bridge, and above full 400 kilowatts, 12 pulse converter. So 12 pulse converter is nothing but back-to-back connections of two three-phase full bridge. So if you take this full bridge, there are 6 thyristors will be there. 6 thyristors. If you take 12 pulse, nothing but twice, two times of three-phase full bridge. That is nothing but a 6 pulse converter. So this is. Let me zoom this one. Okay, okay, enough. So this is nothing but this is single phase full bridge controlled rectifier. This is controlled rectifier. This is freewheeling diode. And look at this one. The output of after freewheeling diode, whatever the output which you are getting, that is connected to DC shunt motor. DC shunt motor. This is RA, this is EB, and this is field winding. So this is the input voltage. This is the input voltage. For the positive half cycle, thyristor T1 and T3 will be turned on. For the positive half cycle, T1, T3 will be turned on. Let us look at the current flow direction. So current flow will be through T1, T1 to load, and again this is positive with respect to negative. Negative is nothing but this is T2 is forward biased. So this is current flow will be in this direction, which I already discussed. And if you give the firing angle at T is equal to 30 degrees, there is a T1 and T3 at 30 degrees. Nothing but if you give the 0 degrees, that will be like this. If you give it alpha, alpha may be anything, alpha 30, 20, 40 maybe. So that will be turned on at this location, and the output is similar to the input. So now at this after 180 degrees, due to the natural computation, there is T1 and T3. These T1 and T3 is junction J1 and J3 automatically reverse biased as per the natural computation. Next, for the negative half cycle, this is negative and this is positive. Positive with respect to this is T3 forward biased, and negative with respect to negative, this is cathode, this is forward biased, and current flow will be in this direction to the load, and again in this direction. And in the same way, this is T3 and T4 will be turned on at the same location. Nothing but if you turn on at this at 180 degrees, the pure form of half cycle will be appear as out. Otherwise, it will be turned on at this position, at this location, and that will come towards the positive side, because current flow will be in this direction only for the positive half cycle. For the negative half cycle, current flow is only in this direction only, so that output voltage appears at the positive side only. So like this, so this will be repeats, and as it is inductive load, as it is RL load, current will be increases gradually, and remaining whatever the energy stored in the inductor, that will be released in this gap only. In this gap only, that will be releases, and again charges for this half cycle. So if you use more capacity of the nothing but if you use this motor with high capacity, so inductive nature is more inductive nature, so that this will be continuous like this, decreases and increases and decreases, and then increases and decreases. So if it is reference, nothing but continuous output will be takes place if you use more value of the inductor of the motor. So this is speed control of DC series motor. So what is the difference between DC series and shunt motor? Only the field winding. For the DC shunt motor, field winding is connected in parallel like this. In this motor, only winding is connected in series with the motor. So let us look at the waveforms of that speed control of this motor. So look at this one. What is there any difference of the previous one and this one? There is no difference. Both are same. So if you use more capacity of the inductor, charges and discharges, and immediately again for the negative half cycle also charges, discharges, and charges and discharges like this. Nothing but this is output, continuous output. We will get continuous output like that. Okay, now. So you should show like this only, continuous output like this. You should not show this is up to 0, because if the current reaches to 0, there is no use of the converters. Okay, in the examination you should draw like this only. This is a charges and discharges, and immediately while discharging of the inductor, again this negative half cycle will come into picture and charges, discharges, charges. So you should show this gap in the examinations. So next one is speed control of DC motor by using choppers. So by using choppers, look at this one. This is nothing but a first coordinate chopper Q1. So V output is equal to alpha times of Vs during this period. This is output voltage appearing across the motor, and in this period current is constantly applied to the motor, and whatever the energy is stored in this way, and if you open the chopper, energy stored in the inductor will be releases in this direction only by reversing its polarity, and so that the output current of the motor is nothing but current of the motor is always constant. So this is nothing but supply current, this is output voltage, this is output current, and this is a freewheeling diode. Freewheeling diode, whatever the current, only the current through the freewheeling diode will be takes place during the off period. Nothing but if you turn off this SCR, then only current will flow in the freewheeling diode. So this freewheeling diode current will be shown in this position. So this is just like similar to the class A chopper or step down chopper. Step down chopper is nothing but this is similar. In place of chopper, there is a switch, chopper switch, and in place of this one, a load will be there. If you want, you can compare. Similar to the previous one, speed control of DC shunt motor, because this is shunt field winding is there. So speed control of DC shunt field winding, the DC shunt motor is similar to the previous one, but the performance of the motor will be different. That is series motor, this is shunt motor. So these output equations, output waveforms also similar to the previous one. There is no difference. There is no difference between DC series and shunt motor. Merits of chopper using DC motor, speed control of DC motor with the chopper. What are the merits? High efficiency. High efficiency because efficiency formula is nothing but output power by input power. Input power. So whatever the output we are, nothing but this is the constant input. We are utilizing only this portion only. Okay, now we are utilizing this portion only. Exactly, we are utilizing. So output will be more, and we are using only this portion as an input only. So if you use, for example, this is a 50, output is, let us assume 40. So this is 50% only utilizing. This is 40 by 50. Again, for example, output is 40. If you use this total 100%, this will be like this. So here efficiency is less, and here efficiency will be more. And flexible control, because smooth control is possible, and lightweight. So because this is as this is a as this electronic devices, so these are in lightweight as compared to rheostats. If you use rheostat, the weight of the machine will be more. So this chopper will be weight of the chopper will be very less, and the small size and quick response. So fast response, because this is electronic circuits, and regeneration of DC supply is possible with choppers. Regeneration is possible only with this choppers. This will be takes place in the hybrid cars. Hybrid cars. So in the hybrid cars, we should use regenerator. Nothing but regeneration is nothing but in which coordinate? Second coordinate. Second coordination regeneration is possible. That is possible with this chopper only. That is not possible with this is control rectifiers. Okay, only that is possible with choppers only. So by using chopper, what are the benefits are there? What are the demerits are there? And by using converters, what are the differences. So let us discuss the difference. Operating principle. So here also operating principle is in the converters AC to DC. AC to DC. Here constant DC to variable DC. Chopper operation, nothing but. Ripples. Ripples is more. Ripples is nothing but like this now. These are ripples more in this AC. Nothing but